Hey there, class. Mrs. Matheson here. We are going to be doing Unit 6, Notes 2 on exponential growth. Our learning target today is I can graph, model, and apply exponential growth functions. So we are going to see growth functions. This is going to be a little bit different than the exponential functions we talked about yesterday. With exponential growth functions, we have a bunch of variables going on in this function. We have C, which is our initial amount or the starting amount, and then R, which is the rate of change, not as a percent. So if you're given the rate of change as a percent, you need to convert it over into just a decimal. And T represents time. So pause the video if you need to get all that down. Make sure you get all that information. So let's go ahead and just jump right into problem 1. We're going to write our equation. So looking up in your box, above, our starting value, C, is 8. And then we're going to put 1 plus, because it's a growth equation, plus 0.45 to the t. Okay, we can go ahead and add these to simplify, and we get y equals 8 parentheses 1 plus, or 1.45 to the t. So let's use, instead of x, let's think of this as t. All right, so now all we're going to be doing is taking our function, or our equation here, and we're going to be substituting in values for t. We are going to continue on with picking -2, -1, 0, 1, and 2. So we are taking our calculator, take 8 parentheses 1.45 parentheses, use your exponent and put in -2. And I have 3.8. Okay, we're going to do that again. Take 8, 1.45 parentheses, and now it's -1. I got 5.5. If we plug in 0, same idea, plugging in 0, we get 8. And then, oops, we're going to do 8, 1.45 to the first. We end with 11.6. And then if we put in 2, we're going to end up with 16.82. Check my answers, make sure that they match what you put in to the calculator. All right, let's go ahead and graph these points then. -2, 3.8. We're going to be dealing a lot with decimals when we're dealing with exponential functions. So go ahead, I'm not obviously going to be like, ooh, that doesn't look like it's 0.8, it looks like it's 0.6. You guys are going to estimate and do your best judgment with putting these points on the graph. So we're here at -2. We're going to go up to 3.8, which is almost at 4. -1, we're going to be up at 5.5. 0, we're up at 8. 1, we're up at 11.6. And 2, we are at 16.82. So way up here. All right, last thing we want to do is connect our points. And notice we're doing exponential growth functions, and so our graph should be going in the upward direction, like they are. All right, let's take a look at problem 2. Problem 2, our rate is given to us as a fraction. That's totally okay. We still have y equals our starting value, 1 plus our 1/3 to the t. Now, we want to get as accurate as we can, so we're going to leave that as 1/3. So y equals 6, 1 and 1/3 t. You have calculators that have buttons for fractions. So you should be able to type in the fraction 1 and 1/3. Okay, that's that ABC button if you have a scientific calculator that you're using. All right, our t values again, -2, -1, 0, 1, and 2. So we're going to take 6 times 1 and 1/3 to the -2 power. So typing that into the calculator, you probably get something like, 3 and 3/8. So if we take 3/8 and divide it, we get 3.4. Reason why I want you to change this to a decimal here at this point is because we don't want to have to worry about graphing fractions, so we'll just graph decimals with this. Okay, I want you to pause your video, and I want you to fill in the rest of this chart, and I will see you back here. Okay, check your answers with mine. And then I want you guys to go ahead and graph this. Starting with your -2 up to 3.4. -1 is up at 4.5. 0 is up at 6. 1 is at 8. And 2 is all the way up at 10.7. So we have a similar picture to our previous graph. We have that growth picture. All right, so let's go ahead and take and apply exponential growth to real world situations. So 3 says, in 1971, there were 294,105 females in high school sports. Since then, the number has increased an average of 8.5% per year. Write an equation to represent the number of females participating in high school sports since 1971. So we're just writing the equation here. We're not actually solving for anything, so we won't have a number answer. So our equation is c parentheses 1 plus r to the t. Remember, c is our starting value, and r is our rate, and I have 8.5% per year. The thing, I feel like there's something I'm supposed to remember about rate. That's right. We want our rate not to be a percentage. So to take 8.5% and make it not a percentage, we are actually going to move our decimal place 2 spots. So there's 1 and 2 spots to the left. Okay, so let's plug in here. Y equals 294,105, parentheses 1 plus 0.085 to the t. We're going to simplify by adding. Y equals 294,105 times 1.085 to the t. And there is our equation. B says, according to the equation that you wrote, how many females participated in sports in 2005? So now it's asking how many. So that's telling us we're coming up with a number solution. We are going to use the same equation that we just wrote. So we have y equals 294,105, 1.085. Now we got to come up with our t. So 2005. Oh, we started in 1971. So let's take 2005 and minus our 1971, not 1997. What are you thinking? 1971. If we go ahead and subtract that, we find 4, 1, 9, 10. We get 34 years. So we're going to put 34 in for our t. Go ahead and take that and type it into your calculator. I'll give you guys a few minutes to do that. Okay, so I have 4,711,000 and 4.36 females. Now we're talking about actually people, so 0.36 is not really a full person. So if you said 4,711,004 females or rounded it to 5 females, that's fine. I'll take either one of those. All right, let's look at our next word problem here. In 2010, the city of Farmington had a population of 21,087 people and a growth rate of 1.9% per year. Write an equation to represent the population of Farmington since 2010. We're looking here for an equation. I'm going to have you guys do that one on your own. B says, what would the approximate population of Farmington be in 2013? So that would be t equals 3, because it's years since 2010, and in 2017. So t would be 7. All right, I want you guys to come up with the solutions for both of this parts of this problem, and when we come to class tomorrow, we will actually talk about compound interest. We'll see you guys then.